Find the perimeter of each polygon. So you're going to add up all the side lengths. 2 plus 2 is 4. 3.6 plus 3.6 would be 7.2. And then we add those together and we get 11.2 inches. Without calculating, describe how you can find the area of the given figure. So it has pieces that are parts of a circle, but then it also has sections that are rectangular. So we can cut the shape up into rectangles and quarter circles and calculate the area of each of those pieces and then find the total. The total of the rectangular pieces and all the quarter circle pieces would be the area of the figure. Problem 2 says consider the figure. Find the perimeter of the figure. And part B says find the area. So the perimeter here we have a 9.22, an 8.06. This side is 1, 2, 3. Here this side is 10. And then this last side is also a side length of 3. So if we combine all of those together, 9 plus 8 is 17. 0.22 plus 0.06 is 0.28. 3 plus 10 plus 3 is 16. Then we can add those together. 16 and 17 make 33.28, and this is measured in units. Then find the area. So we're going to break it up into parts that we know. Here I can cut it across to form a rectangle that is 3 by 10. And then I also have a triangle here that has a base of 10 and then a height of 1, 2, 3, 4, 5, 6, 7. Remember, a triangle is half the base times the height. So the area of this bottom rectangle piece is 30. Half of 10 is 5, and 5 times 7 is 35, giving us a total area of 65 units squared. Number 2 says consider the figure. Find the perimeter of the figure, then find the approximate perimeter by using 3.14 for pi. So here, there's a rectangular piece which has 6, 12, and 6. This diameter is 12, and we're going to use this piece of the circle, which is half of the circumference. Remember, circumference is the diameter times pi. Here I have 6 plus 12 is 18, plus 6 is 24. Half of 12 is 6, so it's going to be 24 plus 6 pi as the perimeter. Then we need to approximate. So this is our first answer. That is as accurate as we can get. But if we wanted to approximate, we would do 24 plus 6 times 3.14 and add those values together. So we'll multiply 6 times 3.14, which is 18.84, and add that to the 24 from this rectangular piece, giving us 42.84 millimeters. Now, we don't use this 12 up here because it's not part of the outside of the shape. So we don't need that additional 12 when we're finding the perimeter. Then it says find the area. So we have the rectangular piece. The base is 12 and the height is 6. And we have a semicircle. The radius of this semicircle is 6. So we'll use radius squared times pi, but it's a half of a circle, so we'll divide it by 2. 12 times 6 gives us an area of 72 for the rectangular piece. 6 squared is 36, and 36 divided by 2 is 18. So this is the most accurate way to represent the area. But then if we wanted to approximate, we would multiply 18 by 3.14, which is 56.52. Add the 72 from the rectangle, and that is 128.52 millimeters squared. So the area and then the approximate area. Find the area of this figure. This is made up of a triangular piece, so half. The base of the triangular piece is 12, and the height of the triangular piece is 5. Plus we need this quarter circle section. So it has a radius of 5, so 5 squared times pi, and it is a quarter circle, so we're going to divide that by 4. 12 times 5 is 60. 5 squared is 25. Half of 60 is 30. And 25 divided by 4 is 6.25 with the pi. And this is in units squared. Then to find the approximate area, we will add. We need to multiply by 3.14, which is 19.625, and add 30 to that, giving us 49.625, but it did ask us to round to the nearest hundredth, so that's 49.63. Oh, and I missed this. It says they are in inches. So inches squared. Sarah uses a square and 2 semicircular regions to design a heart-shaped poster. Find the area of the heart, then find the approximate area using 3.14 to round to the nearest hundredth. So our square here has a base of 7, so it's going to be 7, and it's 7 tall. Plus I have 2 semicircular regions that are the same size. So if I were to connect them, I would have a full circle. So we're going to use plus the radius squared times pi. I don't have to divide it by 2 because I have 2 half circles. This dimension here is 7, but that's the diameter because it goes all the way across. So the radius would be 3.5. 7 times 7 is 49. Then we need 3.5 times 3.5 to get 3.5 squared, which is 12.25 pi. And this is measured in inches. So there's the area. And the approximate area, we have to multiply 12.25 by 3.14, which is 38.465, and add that to 49, giving us 87.465, and round it to the hundredths place. The 5 makes the 6 go up, so this is 87.47 inches squared. Find the area of the shaded region, then approximate by using 3.14 for pi. So this one, the outer section minus the inner circle, is going to give me the shaded piece. So I need 2 circles, but I'm going to subtract them. The outer circle, from the inside to the edge, has a radius of 10. You can see it's at 12 here and at 2 here, so the difference there would be 10. And then the inner circle has a radius of 1, 2, 3, 4, 5. So 10 squared is 100, and 5 squared is 25. 100 pi minus 25 pi is 75 pi, and this is measured in units squared. Then the approximate area, we would multiply 75 by 3.14, and that'll give us the approximation, which is 235.5 units squared. Find the area of the shaded region here. Then find the approximate. So this one has a square, has a base of 26 and a height of 26. And then we're going to remove the circle piece. This is a full circle, so we'll use radius squared times pi. The distance across the circle is 26. So the radius is half of that distance. Half of 26 is 13. We'll start by finding the area of the outer section, the square. 26 times 26 is 676. 13 squared is 169. This one has the pi and that one does not, so we're going to leave them separate. This is measured in feet squared. That gives us the accurate area. And now for the approximation. Multiply 169 by 3.14, which is 530.66. Subtract it from 676, and that is 145.34 feet squared. That's it for lesson 14. The composite figures with circular regions. So composite is just talking about how it's made up of multiple sections, like a rectangle or a triangle and a circle. Break it down into its pieces.